In this video, we're going to work practice problems where we balance complex chemical equations. So a chemical equation like shown here, you've got more than two reactants, more than two products. And you can see here, for example, the compounds can get pretty complicated. Okay, and so to balance chemical equations like this, we're going to use the exact same principles, the exact same techniques that we learned 2 videos ago, where I went through all of the techniques that you use to balance any chemical equation. And then even in the previous video where we balanced relatively simpler chemical equations. We're still going to use those same techniques here. It's just going to be a bit more involved to apply them is all. Okay, so again, using those same techniques, we start out with any chemical equation by seeing if there's any lone elemental forms of a substance anywhere in the reactants or the products. Well, for these complicated chemical equations, that's probably not going to be the case. That's what makes them complicated. And so, yeah, we can see here there's no lone elemental forms. So we're not going to be able to start by ignoring that elemental form and balancing everything else. Okay, the next thing we want to do is see if we can make any substitutions. So, okay, we could potentially substitute for a PO4 group, an NO3 group, an NH4 group. Okay, and the way it's going to work is, in general, you're going to start by making as many substitutions as you can, and then once you make the substitutions, you're still going to need to analyze the resulting simplified equation to see if the substitutions are going to work, in the sense that you can't wind up with, if we substituted for the PO4s, NH4s, and NO3s, that's not going to work because we're going to be left with just only oxygens on the product side of the reaction and no oxygens on the left side. So that's not going to work. We could just substitute for the PO4s. That would work. But we might be able to do a more extensive substitution if we substitute just for the NH4s and the NO3s. So let's try that and leave the PO4s as is. So if we say that A is equal to NH4 and B is equal to NO3, then we've got H3PO4 plus A2MOO4 plus HB. Then we've got, let's see, A3PO4, and then okay, and then AB, and then H2O. Okay, but now we need to check this, though, to see if the substitution is going to work, because we need A groups and B groups on both sides. We can't end up with just a single element by itself on one side of the equation as a result of the substitutions. Then that's not going to work. So we've got oxygens on both sides. We've got A and B groups on both sides. We've got phosphates on both sides. Molybdenums on both sides. Hydrogens on both sides. Okay, so we're good. Let's go ahead and balance this simplified form here. Okay, so we've made the substitutions. There's no elemental forms. The next thing we're going to do is look for elements that occur just in only one substance on the reactant side, and then that same element occurs in one and only one substance on the product side as well, because we're going to be able to relate the coefficients of those substances. So, okay, we've got, let's see, phosphate occurs just here on the reactant side and just here on the product side. So, and they both have the same subscript, so these two coefficients are going to have to be the same for the phosphates to balance. So we put 2 X's there. We don't know what the coefficient is, we just know they have to be the same. Okay, let's see. Now we've got the molybdenum by itself here and the molybdenum by itself here. So like we could have come to the B groups, like the B group is alone here and the B group is alone here, and said, okay, well, these two coefficients, since they have the same subscript, need to be the same. And that's fine, but it's easier to try and, as much as you can, stick with So, okay, we have these X groups here. So try and find another element that's associated with the coefficients you just made. So there's a molybdenum alone here and a molybdenum alone here. There's 12 molybdenums, so 12x molybdenums on the right. So this is going to need to be 12x. You see? Okay, so now maybe we can, instead of looking at the two B groups, we might be able to go ahead and figure out what this coefficient needs to be, because now we can, even though we don't have the A group alone in a single substance on both the left and the right, we have a relation for this for one of the coefficients though. So now we can kind of extend that rule. We can break that rule a little bit, because we can say, okay, if this is Y, this coefficient is Y, then let's balance the A groups. So with the A groups, we've got on the left, let's see, 24x, then this is equal to 3x plus y. Okay, so y is equal to 21x. So there you go. Now we've got, this is 21x, you see? Now there's no more y, so I'll take this out. Okay. Now we can come to the B groups. We could have put two y's here to start, but just to try and make it as simple as possible. So the B group is alone here on the left and alone here on the right. They have this. So this is. So you have 21x B groups on the left and 21x B groups on the right. That's this coefficient. Okay, so now we're just left with this lone coefficient here. We'll say this is y, and to get y as a function of x, we could balance the h's or the o's, whatever. So let's just do the h's, hydrogens. So we've got 3x, and then plus 21x is equal to, okay, so it's just going to be 3x plus 21x, oh, well, 2y. So we've got 2y is equal to 24x. So y is equal to 12x. Okay, so now we've got all of the coefficients in terms of x. And so we're done. Why are we done? We're done because, okay, this is balanced. This equation is balanced for whatever x we choose. No matter what x we choose, I guess other than like a negative number, as long as it's not a negative number or zero, the equation is balanced. So we're going to choose x to be equal to 1, right? For the simplest whole number coefficients. So, okay, there you go. So this is going to be 12. This is going to be 21. This is 1. This is 21. And this is 12. And that's the balanced equation. Okay, same process. We start by looking for lone elemental forms, because then we have any lone elemental forms, we're going to ignore those elements and balance everything else to start with. But you can think about how for these problems, if these are complicated, we're not going to have any lone elemental forms. Okay, so the next step is you want to, in particular for a very complicated chemical equation, you want to make as many substitutions as possible. Okay, so we've got SO4s on both sides. Like that's the first thing to look for. If you don't have a group of elements on both sides, then you can't substitute for it. We've got SO4s on both sides. We have NO3s on both sides. No. Okay. So it looks like we could substitute for an SO4. Well, no, we can't. Yeah, because look at the issue here. If we substitute for an SO4, look at what would happen. You have to be careful with this. So this goes away, this goes away, this goes away. We don't have any sulfurs on the right. Okay, now, but this sulfur is gone. That's not a problem as long as we don't have any extra sulfurs on the left, and we'll have a sulfur here. So then if we make the substitution for SO4, we won't be able to balance the sulfurs. So we can't substitute for SO4. What about Cr2O7 or nitrate? No, so we can't make any substitutions here. Okay, that's not a problem. We just go through the same steps. Let's look for lone elements on both sides in just one substance. So we've got sulfur is not alone on the right side or on the left side. What about, let's see, nitrogen? Nitrogen is alone here on the right in this substance, this compound, and it's alone here on the right. Alone here on the left, alone here on the right. So, okay, we've got 6 nitrogens here. So, okay, if this is X, then this is going to have to be 6X. This coefficient has to be 6 times this coefficient, or else the nitrogens won't balance. Has to be. Okay, let's see the carbons. I'm sure carbon is not by itself on the right, or it is. Okay, you just have carbon here in CO2, and just carbon here in this compound. So, okay, you have 6X carbons on the left, so this has to be 6X. All right, what about iron? Iron's alone here, and it's alone here. We've got, let's see, X carbons on the left, so this needs to be X divided by 2. 1/2 X times 2 is X. Let me put 1/2 X. Okay, now let's see, potassiums. So I don't think we have any more lone elements, but we might have enough coefficients now to where we can solve for another coefficient. So, but I mean, even if we can't, we could still just put like a new variable. It's not a problem. So let's see. Yeah, I mean, we can do that. So the chromium is alone here on the left and alone here on the right with the same subscript. So these two are the same. They have to be. But we can't, at the moment, we can express these in terms of X. Okay, so now, okay, if we say this is Z, we can go ahead and balance the potassiums and solve for Z as a function of X and Y, and then just replace this with some X and Y. So, okay, let's balance the potassiums. We've got 4X plus 2Y is equal to 2Z plus 6X. Okay, so 2Z is equal to 2Y minus 2X. Z is equal to Y minus X. Okay, so you see, so now we can replace this with Y minus X. All right, now let's see. Hydrogens are alone here and alone here, so we can say if this is, that these have to be the same because you have H2 and H2. So now let's let's do the hydrogens. Doesn't matter, just whatever we haven't balanced yet. You know, we've technically balanced the chromiums and the nitrogens, right? So let's balance the hydrogens and solve for Z. So, or no, we just balanced the hydrogens. So no, we'll need to balance what have we not balanced yet? The sulfurs. Let's do this. We haven't balanced the sulfurs and the oxygens. So let's do the sulfurs. Okay, so 6X plus Z is equal to then 3/2 X plus 3Y plus Y minus X. So Z is equal to, let's see, 3/2 minus 1 is 1/2 X plus 4Y minus 6X. Okay, 1/2 minus 6 is minus 11/2. So 4Y minus 11/2 X. Okay. Okay, now we just need to get rid of these Y's. Get everything in terms of X. So we just we have one more element we haven't balanced, the oxygen. That's going to give us Y as a function of X. So, okay, we've got 7Y plus 16Y minus 22X is equal to, let's see, 12 times, You got 6x plus 12y plus 12x plus 4y minus 11 halves x plus 4y minus 4x plus 18x. So, okay, we've got 23y minus 22x. Then let's see. 6 plus 12 minus 11 halves minus 4. 53 over 2x. And then, let's see, 12, 16y. You got 20y. Okay. So subtract 20 from both sides. You've got 3y, and then 53 over 2 plus 22. 97 over 2. So y is equal to, divide this by 3, 97 over 6, x. Okay, so we've got okay, now let's just plug 97 over 6 for y in here. So 97 over 6 times 4, 194 over 3x, and then minus 11 halves. 355 over 6. So okay. Okay. Now we just need to multiply this. Oh, no, we have y minus x here. So 97 over 6x and then just minus 1. 91 over 6. Okay, now we just need to multiply this entire equation by 6. Right? If you multiply an entire chemical equation by a constant, it doesn't change the balance. So, okay, we're going to get 6x here and then 97x. $355x, then 3x, and then 97x, then 36x, 355, and 91, and then 36. Okay, so now we've got everything in terms of whole numbers. We just pick whatever x we want. We're going to pick x to be equal to 1, right? So 6, 97, 355, 397, 36, 355, 1. Okay. And there you go. That's the balanced equation. Okay. There's no lone elemental forms. Now, can we make any substitutions? Looks like we can do a PO4 and maybe an OH. So we won't be left with any lone phosphates. With the OHs, we'll still have oxygens and hydrogens on both sides. So yeah, let's do A is equal to PO4 and B is equal to OH. So we've got H, A, okay, plus Na, okay, now Na2, H, A, plus CaB2. All right, so now this is a lot simpler to deal with, right? Okay, so now let's see. We've got a calcium by itself here and here. These coefficients have to be the same. We've got a sodium by itself here, but let's see if we can relate something with involving the X coefficients. Yeah, so we've got the B by itself here and here. So this is 2x. This needs to be 2x. Now we can relate the sodiums. So 2x sodium's on the left. Okay, great. So, I mean, yeah, now we say this is Y, and we just balance the hydrogens or the oxygens to solve for Y in terms of X. So let's just do the hydrogens. It doesn't matter. So, all right. 4, 5, that's 5x. Is that right? 4, 5, yeah. 5x plus 2y is equal to, let's see, 25x. And yeah, that's it. So we've got 2y is equal to 20x. So y is equal to 10x. And there we go. Let's just set x equal to 1, and we've got 2, 10. And that's the balanced equation. Okay, so here it looks like we can substitute for a sulfate group. You've got sulfates on both sides, and there's no extra sulfur running around here like there was before. So, okay, if we say that A is equal to SO4, and it looks like that's all we can substitute for, then we've got, so K4, then K, let's see, KH, all right, plus okay, now let's look for lone elements on both sides. So we've got iron just in this compound on the product side, and then iron just here on the reactant side. So if this coefficient is x, this coefficient is going to have to be 2x. Okay, you've got nitrogens alone here on this side and alone here. So you've got 12x nitrogens on the left. So this is going to have to be 12x. And then carbons alone here and alone here. So this is going to have to be 12x as well. Okay. Now you've got manganese is alone here and alone here. Same subscript. So these two coefficients are going to have to be the same to balance the manganese. Now, okay, we can see that in order for the potassiums to balance, this is the only potassium on the reactant side. On the product side, there's 8X plus Y potassium. So this is going to have to be 8X plus Y. Okay, now let's see. For the A groups to balance, if this is Z, then on the reactant side, you've got ZA groups. And then on the product side, we've got 8X plus Y plus Y plus 3X. So 11X plus 2Y is Z. Okay, now if this is Z and we balance the, let's say, the hydrogens, we've got, so 22X plus 4Y, hydrogens on the left, then 8X plus Y plus 12X plus 2Z. So 22X plus 4Y, then 20X plus Y plus 2Z. So 2Z is equal to 2X plus 3Y. So Z is equal to X plus 3/2 Y. Okay. Now let's balance the oxygens. So we've got 4Y. Oxygens on the left is equal to 36X plus 24X plus X plus 3/2 Y. Okay, so subtracting 3/2 from both sides, you've got 4 minus, so 5/2 Y is equal to 36 plus 24 is 60 plus 1. Okay, so Y is equal to 61 divided by 5, 122 divided by 5X. So now let's substitute Y so we can get everything in terms of X. So okay, now let's see, so 2 times Y plus 11. 299 divided by 5. Okay, now 8X plus Y, so okay, just Y, 122 divided by 5, plus 8, 162 divided by 5. Okay, now 3/2 times Y, so there's Y times 3/2, and then plus 1. 188 divided by 5. Okay, now let's just multiply this entire chemical equation by 5 to clear the fractions. We're not going to change the balance, right, if we just multiply by everything by the same number. So, okay, we've got 10x here. This is going to be 5x. Well, I don't want to confuse myself. So, okay. This will be 122x and then 299x. And then 162. And then 5. And then 122. And then 60. 12 times 5 is 60. And then 188. Okay. So now if we set x equal to 1, we get and there we go. That's the balanced equation. Okay, so here, maybe we could substitute for a C2O4 and an H2O group, because we've got both of those groups on, they're on both sides. But the problem with that is we're going to be left with oxygens on the left, but no oxygens on the right. So we can't do that. So we'll just pick one to substitute for. Let's say that A is equal to C2O4. So, okay, that results in okay. And then K3 okay. So we can start with that. We've only got one product, one compound on the right, so that's nice. These two coefficients are going to have to be the same for the ions to balance. Okay, now well, actually, let's do this. Let's make this 2x and this 2x. So it's still the same coefficient, but now we can see that there's 6x potassiums on the left, so this needs to be 3x to balance the potassiums. Okay, now instead of doing the A groups next, because the A groups are in a lot of different substances, let's look at the oxygens. So if this is Y and we balance the oxygens, so that's going to be 4x, we're doing the oxygens, 4x plus 2y is equal to 6x. Then we've got 2y is equal to 2x, so y is equal to x. So this is going to be x. Okay, now let's focus on the hydrogen. So if this is y and we balance the hydrogens, we've got 4, so 8x plus 2y plus 2x is equal to 12x. So 2y is equal to, it's 8x plus 2x is 10x. So it's 2x, so y is equal to x. Okay? All right, now let's set this equal to y and balance the A groups. So 2x plus x plus y is equal to 6x. So 3x plus y is equal to 6x. Y is equal to 3x. Okay, so set x equal to 1, and we've got 2, 3, or no, that would be, is that right? No, so this is 3 here and then 2 here. And that's the balanced equation. Okay, so here maybe we could substitute for a sulfate group. You've got sulfates on both sides, but then we're going to be left with this lone sulfur on the left. So now we can't, there's not nitrates on both sides. There's not Cr2O7 groups on both sides, so we can't make any substitutions. Okay, so let's just look for, we've got a potassium here, just in this compound, and then a potassium here, just in this compound. So if this coefficient is X, then this is going to have to be 3X to balance the potassiums. Okay, what about the irons? You have iron alone here, iron alone here. So this is going to have to be X to balance the irons. Okay, you've got nitrogens here, but then nitrogens in more than one spot. What about carbon? 6X carbons on the left just in this compound, and there's carbons only here. So this is going to have to be 6X. Okay. What about sulfur? No, you got a bunch of sulfurs everywhere. Okay, now let's see. You've got, for the chromiums to balance, these two coefficients are going to have to be the same. And then for the sodiums to balance, all these need to be the same coefficients for the sodiums and the chromiums to balance. Okay. Now we can, okay, if this is Z, let's balance the sulfurs. So 6X plus Z is equal to 3Y plus Y. So Z is equal to 4Y minus 6X. Okay, now for the hydrogens to balance, you have hydrogen alone here, hydrogen alone here. This is going to have to be 4Y minus 6X. Okay, now let's balance the oxygens. So we've got 7Y plus 16Y minus 24X is equal to 9X plus 12Y plus 12X plus 4Y minus 6X plus 4Y plus 9X. So, okay, 23Y minus 24X is equal to 21X minus 6X is 15X, plus 9X is 24X. And then 12 plus 4 is 16 plus 4, so 20Y. Okay, subtract 20Y from both sides, you have 3Y. Add 24X to both sides, you've got 48X. So is 16. Okay, so we've got now 4Y, 4 times 16 minus 6 is 58. So okay, there we go. Now let's just set X equal to 1. And there we go. There's the balanced equation.